Welcome to the 9th lesson in measurement for the CSEC mathematics series. In this lesson, we'll learn how to solve problems involving speed. First, we'll define some terms and then we'll work through examples to help you understand how to use the formula. The first term we're going to define is distance. Distance measures how far an object has traveled along a path. We call it a scalar quantity. A scalar quantity means that we're only considering how much distance we cover without regard for what direction we move in. Distance is usually going to be measured in kilometers or meters. The next term is time. Now, time measures the duration over which events occur. For example, if you want to measure the amount of time it takes for a cricket ball to leave a bowler's hand and reaches the bat of the cricketer, that will be the duration of the event that we're measuring. In our calculations, we will use units like seconds, minutes, and hours to measure time. The next term that we should define is called speed. Now, speed tells us how fast an object is moving. It is calculated by dividing the distance traveled by the time taken. Speed is measured in meters per second or kilometers per hour. Remember to keep your units consistent when working with this formula. For example, if your distance is measured in kilometers and your time is measured in seconds, you cannot express your speed in meters per second. You can express your speed in kilometers per second because you measured your distance in kilometers and your time in seconds. Sometimes the relationship between speed, distance, and time needs to be adjusted so that you can determine unknowns. However, this is usually done with algebra. So before we move into algebra, I'll show you a simple method using this triangle to find any unknown when the other two values are known. To find a specific value, cover the term you want to solve for, and the triangle will reveal the formula. For example, if you want to find the distance, we need to cover the distance in the triangle, and you will see that it equals speed multiplied by time. If you want to find for time, we cover time, and you'll get that the distance divided by the speed gives you the answer for time. We'll use this triangle during the example so you can see exactly how it works. The final term we need to define is average speed. Now, average speed is defined as the total distance divided by the total time. While it may sound like speed, it's different. Average speed provides an overall rate for the entire journey, smoothing out any changes that might happen in speed, whereas speed reflects a specific moment. So even though the formula is similar, the concepts are different. Let's solve the first example. A car travels 150 kilometers in 3 hours. What is its average speed? Let's look at the second example. A cyclist travels at a speed of 20 kilometers per hour for 2.5 hours. How far does the cyclist travel? Let's try example 3. A train travels 240 kilometers at a speed of 80 kilometers per hour. How long does this journey take? Let's look at example 4. A runner completes a 10-kilometer race in 50 minutes. What is the runner's average speed in kilometers per hour? Example 5. A vehicle travels 100 kilometers at 50 kilometers per hour and then another 150 kilometers at 75 kilometers per hour. What is the average speed for the entire journey? All right, and that's it for today's lesson. We defined distance, time, speed, and average. We looked at the relationship between speed, time, and distance, and the relationship between average speed, total distance, total time. Then we used the relationship between the three quantities to determine unknowns. Thank you for joining me in this lesson on speed. In the next lesson, we'll learn about margins of errors in your measurements. Feel free to leave any questions or comments below, and don't forget to join the Google Classroom for the series resources. See you in the next lesson. Bye.